Hey again, here's another quick intermission. I hope you've already learned a ton from the course. Have you seen the benefits of writing good clean code? Has the course already helped you understand some more advanced concepts? I really hope the answer is yes to both those. Remember to follow the website page as you follow along. I will be adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for a lecture and compare with your own. And definitely check out the related videos when I reference them. This course is focused on making this game, but you should definitely learn more about some of these concepts in more detail, and you can learn that in the videos that I mentioned. By the way, if you're watching this right now, this is the secret callout, so go ahead, post a timestamp in the comments with a nice monkey emoji. I want to see how many people make it this far. Okay, so that's it for now. Let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to apply some collisions to our player movement. Okay, so here we have our game so far. We have our player walking around and everything looks pretty good. However, now let's create over here in the hierarchy, let's right click, create a brand new cube. So there we go, let's place it over here and push it down. Okay, there's the cube. Make it just a little bit bigger. So there's the cube, and by default it has a box collider component, so it has physics. And the player, if I move, and nope, there's our issue. The player is going right through the object. Now the player is not meant to be a ghost, so let's fix this. Over here in our player script, we are carrying the input vector, calculating the move direction, and then just moving the transform. So right now we're moving it no matter what. Now before we do that, let's first do a test to see if any object is in the way. And how we're going to do that is by firing a raycast. This one is a physics operation that basically fires a laser from a certain point towards a certain direction and then tells you if it hits something. How we do that is let's go inside the physics class and let's call the raycast function. This one, as you can see, has many versions of this function with all kinds of parameters. Let's use this one, option number 7, which takes a vector 3 for the origin, a direction, and a max distance. So first for the origin, that is from where we want to fire our raycast, let's put the player object in, so that's transform.position. Then for the direction, this is going to be our move direction, so let's use our move there. And finally for the distance, let's use some kind of player size, player width, something like that. So let's define up here a float for the player size and put that 0.7 units. Let's try out with the size just like this. Okay, so basically this returns a boolean. It's going to return true if it hits something and false if nothing is in the way. So let's just do a bool, call it can move, and basically we can move if this raycast doesn't hit anything. So we can move if this one is false. So if the raycast is false, then can move is going to be true. That's very simple. So if we can move, then we move the transform position, otherwise we don't. Okay, that's it, super simple. Let's test. So here we are, I can move around, and if I go towards the cube, and nope, no longer works. So I can no longer go inside that cube. Okay, great. Now in your case, if it's not working, first of all, make sure that the cube, make sure it is touching the floor. We use the transform position as the origin, which is right on the floor. So if the box is raised up, then you won't be able to go through, so make sure the cube is touching the floor. Also make sure the cube has a box collider component. It can be any type of collider, but if you made a cube, then it should have a box collider by default, and it should have the same shape as the visual. And also remember that the 2D and the 3D physics systems, those are completely separate. They are completely different worlds. So make sure you're using 3D components and not the 2D ones. So for example, if I add box collider 2D, if I add this one, then it will not work. So make sure you're using the 3D and not the 2D components. Same thing over here on the script, make sure you're using physics and not physics 2D. Also finally, if you're still having issues, make sure you check the player position. Again, the player should be on a Y of 0. The only thing that might have an offset is the player visual, although if you're using the same asset as me, then this one should also be on a Y of 0. So all of these on Y of 0. And then you can also check the floor. By default, this one has a mesh collider, but if it is exactly on Y of 0 with no rotation, then it shouldn't cause any issues. Alternatively, you can also just disable or remove the mesh collider from the floor, since we're not going to need that. So with all of that, yep, everything works. I can move the player, but I cannot go through solid objects. Alright, awesome. So it is working. But for this particular use case, a raycast isn't necessarily the best method we should use. Basically, a raycast is, like I said, kind of like a super thin laser. But as you can see, the player visually has an actual body shape. So the visual and the logic are using completely different shapes. If I go ahead and push towards the box, you can see it works just fine. However, if the player is a bit more off to the side, and the center of the player right in front of it is not the box, and I move, and yep, there you go, now I am going through the box. The reason is because the raycast is being fired from the center of the player, and like I said, it's kind of like an infinitely thin laser, so it has no shape. So as long as the center of the player is not hitting the box, then it can go through it. Whereas what we really want is for the visual and logic to have pretty much the same shape. So let's not use a raycast. Over here on the code, instead of a raycast, we can use a physics query with an actual shape. There are all kinds of casts you can use. And as you can see, all of them with different shapes. So you've got a box cast if you want to have a box, a capsule if you want a capsule, or a sphere cast. All of these work pretty much the exact same way, except instead of a raycast which fires an infinitely thin laser, these are going to have an actual shape. And for player controllers, for the most part, you really want to be using a capsule cast. That's usually the generally accepted player shape, although alternatively a box cast also can work very well. In our case, let's just go with a simple capsule cast. This one, to define a capsule, has a 0.1 and a 0.2. By the way, if you have no idea what is a capsule, then we can go over here in the hierarchy, let's right click, create a 3D object, let's make it a capsule, and there you go, this is a capsule. It's kind of like a stretched sphere. So it has round the top, round the bottom, and then over here in the middle, it's just a cylinder. And over here for the raycast, takes a 0.1 and a 0.2, so that is going to be the bottom of the capsule and the top of the capsule. Basically, with those 2 points, we can define the height of the actual capsule. Okay, so let's just get rid of this capsule, let's just delete it. And over in the code, let's put those. Now for 0.1, it is indeed going to be the transform dot position, since that is the point at the bottom. And for the second point, for this one, it's essentially going to be the player head. So we can take the transform dot position, so this is the bottom, and we can essentially just lift it up. So let's add a vector3 dot up and multiply by some kind of player height. So let's define up here a float for the player height. And I tested it in the editor, and the player is about 2 units tall. So over here, let's go ahead and move it up by that much. Okay, so next we want the radius. So this is pretty much the player size that we defined previously, so let's use the same thing. But as always, let's make sure to write good clean code. Since now we are referring to a radius, let's actually rename this to be a bit more clear. And by the way, here's a quick Visual Studio tip. You can right click on a symbol, and then you can click on the rename option. Alternatively, use the shortcut Control R, Control R. If you do that, then now you can change the name. So for example, player radius, and note how it changes every single instance of that variable. So this renaming feature is extremely useful. Always make sure to rename something if you find the name that works best. Okay, so let's rename this to player radius. Then we have direction, so that is as usual going to be our move direction. And then finally we have the move distance. For that we can use the actual move distance. So that is going to be the movement speed multiplied by time.delta-time. So I just find here a float for the move distance. And we just do that, just move speed, time.delta-time. We have the move distance, and we use it both in here as well as down here. Okay, so here we have our capsule cast. The rest of the logic is exactly the same, so if this one is false, that means it didn't hit anything. So if it didn't hit anything, then we can move, and then we move the transform. Okay, let's test. And over here, now if I go towards the box, and yep, still works exactly the same as previously, that's great. And now if I go towards the edge, and make sure that the center is not hitting the box, and now I try to move forward, and nope, now we no longer go inside the cube. So even on the edges, everything still works perfectly. Alright, awesome. So it works, it looks good, but it also is a little bit janky. For example, let's stretch this cube out a little bit, so let's put it just on one direction, so stretch it like this, let's see. Now if I move towards it, then nope, I cannot go through it, so that is correct. And if I move left and right, yep, that's also correct, that works. However, if I now press W and D at the same time in order to move diagonally, and nope, right now it does not move. The reason is because the diagonal vector, that one is indeed hitting the collider. But usually in games, when you move diagonally and you cannot move in one direction, then it tries to essentially hug the wall and move around it. So if I press W and D, it should essentially be moving straight to the right. So let's solve that. So here in our code, we're making our capsule cast. Okay, that's great. Then we need to test if we cannot move. So let's do if we cannot move. So if can move is false. If so, then that means we cannot move towards this direction. And if we can't, then essentially we basically want to split the movement direction and just move on the X or just on the Z. So first, let's attempt just the X movement. So attempt only X movement. Let's create a new vector3. Let's call it move dir X, and we make a new vector3. Let's take in the move dir.x, then 0 on all the others. So we only want to test moving in the X direction. And then let's do literally the same thing. So let's get our can move, try to move under this direction. So let's go instead of move dir on the X. So we do that capsule cast. And if we can move, then that means we can move only on the X axis. So can move only on the X. And if so, let's set the move dir equals the move dir X. So if we can move, then down here when we use the move dir, we're going to move only on the X. And if we cannot move, then that means we cannot move only on the X. And if so, then let's attempt only Z movement. So over here, again, let's do the exact same thing. So let's copy this. Let's just change this one. So instead of move dir X, we've got move dir on the Z. So over here, we use 0 on the X, 0 on the Y, and access the move dir and get the Z. Then let's use this movement direction over there. And finally, the same thing. So if we can move, then that means we can move only on the Z. And let's set the move dir equals the move dir Z. And if not, then we cannot move in any direction. Okay, so that's it. Now this might seem a bit confusing, but it becomes a lot more clear when you see it in action. Again, remember the scenario we're trying to solve, which is when moving diagonally. So for example, when we're moving forwards and to the right. If we do that, then let's say this one is going to hit something, so we cannot move. So if we are trying to move both forwards and to the right, then we're going to only attempt the X movement, so we're only going to try moving to the right. And then we're going to see, yep, going to the right, that does work, so we can move, and we're going to move just to the right. Alright, so let's test and see if all of this is working. Alright, so here we are, and if I move straight to the wall, and nope, there's a limit, so I cannot move anymore. Okay, great. Now if I move just left and just right, then it does work. Now if I press W and then D, and yep, there you go, now it does hug the wall and continues to move. Same thing if I go on the left, so over here if I press D, no I cannot go through it. Now if I press D and S at the same time, and there you go, it hugs the wall and moves around it. So now our controller is much more easy, much more understandable. Okay, so this is great. Now this is one of those tiny things that makes your character controller feel much more responsive, so that's great. However, we also do see one more issue. Right now you can see that I'm right next to the wall, and if I press A and D, then look at that, I'm moving with this speed. However, now if I press W and D, look at that, now I'm moving diagonally and it's actually moving slower. Basically, this is the same issue that we saw previously where we had to normalize the input so we didn't go faster in diagonals. Basically, now we have the opposite problem. Since we are normalizing the vector, we are cutting down on the left-right vector. And with that, basically, if we are moving diagonally, then we are essentially going slower, whereas if I stop moving diagonal and just move left-right, it moves at a different speed. Now, the solution for this is really super simple. Over here in our code, when we are constructing the move dir X and move dir Z, when we do this, very simple, let's just normalize it. So if this one is less than 1, then it will be going into 1. So let's normalize that one and that one. Okay, that's it. Let's test. And now if I'm here, move forward and hug the wall left, right, yep, it does work. And if I stop moving diagonally and just go left, right, yep, all still works with the exact same speed. All right, awesome. Okay, so that's really it. As you can see, it's super simple to add collision detection to your movement scripts. You just do a physics query to test if our character should move and just move it. By the way, if you want to learn more about collisions and physics queries, there's a bunch of interesting videos that you can watch. For example, one is on various methods of finding a target. Then another one is on various methods of handling projectiles. And finally, another one is a very quick checklist on why collisions are not working. Basically, there's lots of really interesting things you can do with physics, so make sure you understand these functions. Okay, so now that we have all of this working, let's first just clean up our scene. So over here, our default cube, we don't want this, so let's just get rid of this. And with this, we are ready to build our first sketch encounter, and let's do that in the next lecture.